Hello again from Border Home Inspections. In today's home hint, I'm in an attic space, and I've been anticipating this video for some time, and it's not actually an easy one to make because there's so much that I have to talk about. But we've had about a month of really cold weather. So in some of the older homes in particular, the vapor barrier is not that great, and there's a lot of heat loss up into the attic space. And I'll go into some details about that. But essentially, in this attic today, I've been called to ascertain why there is leaks coming through the ceiling. And I refer to this as attic rain. So what's happened is we've had a big change in temperature, and now the attic space, the frost that's developed in the cold weather due to the heat loss coming up through the attic space, is now dripping down from the sheathing on top of the insulation. And in some situations, it's more concentrated than others. And let's have a look at that. Okay, so here we see the frost that's developed in this attic space, dripping off the nails. And you know, to some degrees, it's going to be normal to see a little bit of frost after this kind of cold spell that we've had and the change in weather. But this, what you're seeing here, is not normal. Okay, so it's not good. You can see that the water's dripping down. Already I've got lots of drips on my jeans from just sitting here videoing. You can see here what's happening. It's dripping everywhere, but it has a tendency to run down and hit a joint. As you can see that line right there. And then if we look down at the insulation, you can see that there's a concentrated point right there where it's dripping. So what can happen in that situation is where it runs down and hits the joint and sheeting, it will drip at that location, and it tends to be more concentrated. It'll go down and hit the vapor barrier. Oftentimes I find vapor barrier is very wet, but there's no leaks coming through the ceiling. So thank goodness for vapor barrier. But then there's other times when you have a concentration of moisture in a spot like this where the vapor barrier has a bit of a hole in it from a nail or around a light fixture, and water dripping in around your lights and so on. So what's the solution? This is the question. First of all, if we can eliminate the heat from rising up into the attic so readily, and let's face it, a home in minus 40 temperature is going to lose heat. Insulation is not there to stop heat loss. It's there to slow the heat loss. So the question is how do we stop the frost from developing? So the frost is developing because you're hitting your dew point. So there's a certain point where the humidity in the air will touch something cold and it'll turn to frost like this has. So the key here is stopping the humidity from traveling through your ceiling. And the best way to do that is through vapor barrier. And of course, do not pump any kind of moist air like your bathroom fan and so on up into an attic space. Although this looks pretty bad, I've seen it much worse. I've seen it 2 inches thick. Of course, that adds so much more moisture to the insulation. So when the insulation gets wet, of course, it's going to compact and it's going to lose some of its R value, making the problem worse for the next time this occurs. So you can see how wet the insulation is here. The good news is that in the summertime, in the springtime, the attic actually gets quite hot and it actually dries this up. So a lot of times we don't even know what's happening. But in a swing temperature like we've had recently, these people are finding out the hard way that it has definitely caused frost. And now we have, again, what I call attic rain. I don't know if that's a technical term or not, or even where I heard it first, but that's what I call it. So it's dripping down, and if it was even warmer out today, it would be worse. It would happen quicker. And the quicker it happens, the more likely you're going to see water coming through your ceiling. So, because I know a lot of you are facing this, and it's not fun. So one more thing about this while I'm up here. The attic needs to be ventilated as best as you can. You want the outside temperature and the inside of your attic space above the insulation to be at the same temperature. So to do that, you got to have good soffit vents. So lots of air coming up through the vent down here. It rises up and it goes out through the vents in the roof. And this house does have some vents in the roof. It doesn't look like it has any vents in the gables. So that's something I would recommend, adding some gable vents. If you can get air moving through here, then you don't get as much frost. And why is that? So in my estimation, what happens is the air comes up through the insulation, the humid, moisture-laden air. It's getting through the vapor barrier somehow, and it's rising up into the attic. It comes through the insulation. As soon as it touches here, it creates the frost. to prevent it, what you have to do is you have to move the air. So you want the air that's coming off the top of the insulation. Let's say it's 2 degrees above zero and it's minus 15 in the attic. You want to try to cool that air that's coming through the insulation before it touches here. If you can cause the condensation to form basically between the two and not on the sheathing, that's best. And the best way to do that is to have air moving through the attic space. So it's grabbing that heat that's coming up through, and it is hitting its dew point in the air instead of on the surface. And I'm not a scientist, I'm not a expert in this, but this is what I see as happening. And if there's anybody out there that wants to explain this better than I can, I would be glad to listen. But essentially, you want to move the air before it touches the sheathing. You want to cool it down. That's why we want the above the insulation to be as cold as the outside, so that condensation, that dew point, doesn't happen in the attic. And it's almost always worse down at the bottom because the distance between the top of the insulation and the sheathing is close. So even if you're venting your bathroom fan, if you vented it right here above the insulation, by the time it takes to reach all the way up to here, it's cooler and doesn't create as big a problem. But if you bring that bathroom vent fan right up close to the sheathing and then vent that more moist air, it hits something that's cold and it creates the frost. So as a homeowner, you need to try to figure out where you're losing the heat from the house. What are the areas that is causing the most problem? So if you look here, you can see that we've got frost galore, right? So we've got about an inch and a half of frost in this joist space, but the joist space next to it is much less. So overall, the attic space is moist, and there's been some heat rising up through in the cold months, in the cold weather, creating the frost. But in this joist space, we have a much worse problem. And why is that? And the reason for that is because we have a chimney probably flashed improperly. And that has been a problem for many years, as you can see here. The sheathing on the roof is rotten, and the insulation around the chimney and so on. So from down below, where the problem is occurring in this house, is nowhere near here. But it could be running down the vaulted ceiling and coming out at the bottom. And you think the problem is just occurring at the bottom when really it's occurring way up here. So as a homeowner, it's your responsibility to climb in your attic and find this problem. Try to narrow it down as to where the problem is. And then, of course, when conditions are right, summertime, you get up in here and you find out why this is happening. That's all I got for now. Hopefully this has helped a few people and you can make some changes to help make your house healthier.